My name is Ingrid Melve. I come from UNINETT, the Norwegian academic network provider. This is a presentation of some work that the National Academic Network in Norway has done together with the University of Oslo. The goal in the system that we are designing is, the problem we're trying to solve is access control in a heterogeneous, loosely coupled system, which means we have lots of independent units of different manufacturer, running different software, controlled by various people in many different security domains. This is just to make it hard for us. Everything in a single control is easy. We're trying to solve the problem. What we would like to do when doing access control is to replace the current system-specific and, in many cases, single-vendor access control systems. And we want to do this and still protect the user's privacy in cross-institutional authentication. We are building a big system that will cover everything from authentication, authorization, user management systems, PKI, the whole thing. But this presentation is about the user management system authentication server part of the system that we are currently implementing. It's recent results, we haven't done everything yet. The way we're going about the solution to the problem is that we want to replace locally maintained user databases, normally on a per server basis. For instance, each individual web server has its own htaccess files and it has its own user database. We want to replace those with a global authentication mechanism. And the project we're doing this one is called VIDOS, which stands for the common, that's the F in Norwegian, Electronic Person Identity for Education. And we are basing us on the authoritative systems that exist and currently manage information about users. We're not basing this on new systems that we invent, but we are basing it on the existing procedures, rules, regulations, ways to do things. And we are building or improving on existing user management systems. In our case, we call it a BAS, which is the Norwegian for user management system. So your Norwegian will improve as a result of this talk as well. We've also set up an authentication server. And what we do is we export data from the user management system onto an authentication server. And we have collaborating authentication servers. And the way they collaborate is by giving out an index. And then we have an indexing server that gives out referrals. So questions about the specific user is sent to the right place. This is what the system looks like. The yellow thingy is just a normal client. Could be any kind of client. In theory, that could be a Radius client or a web client, whatever. The green part is a server. And as you can see, the faded part is just a tiny, tiny bit that we add on to the server. We don't modify the client at all in this current implementation. We have an authentication server named AT. And we have an authentication server index. And that's the central part of the system. And then there's the hard part, which is the stuff that you have to do at each individual university, which is take your internal systems, the ones at the bottom, the light blue, pale blue ones. SO is the student admission system. There's one in the country, so we're lucky there. They export data into the student registries, where we have two different systems. LT is one of the payroll systems. We would dearly have loved to integrate with the human resource systems, but they're kind of non-existent or strange, or running on very many different platforms. So we are integrating with the payroll system. The good thing about that is that the payroll system is updated. And it keeps current data about who's employed, who's not employed, who's getting paid, who's not getting paid. And if those systems fail, they get fixed. And this is not a hypothetical thing. One of the second biggest university in Norway didn't pay out wages in the month of June last year because they had a major software problem. That was painful. All their data is updated. The operational system status right now is that the user management system is operational at the University of Oslo. Several of the colleges, I probably should say universities because they really are universities, or they run the first 4 or 5 years of university education. The Norwegian education system is a bit different from anyone else's. They are partly operational. Most of the big ones are partly operational. What they need to do is adjust the schema they use for presenting information about their users. There's some software available developed by the University of Oslo. It will become available with a GNU public license later this summer. And Bård is hoping for long summer because he's programming it, and it's turned out to be a bit more work than we intended. And that integrates with one of the student registry systems called FS, and it integrates with one of the major payroll systems. So we can actually get data from there into the user management system. The current use we have, we need unique IDs to identify users. And currently we're just using user at Realm, where Realm is a DC component. So you are something. I am at UNINETT.no would be my user ID currently, just using the username. And that's what's seen from the user perspective. Internally, inside the system, we're using social security numbers because they're unique per person, and they don't change that often, even though some people change the social security numbers when you change your birth date or you change your sex, or you have to go into hiding because your husband beat you up too many times. Those things happen, but they're rare. So we can use social security numbers for data integrity checking. We also have support for multiple identities, multiple unique IDs. One of the things that we want to use, and we're waiting for the work from David Chadwick, is in the Terrena project, is to have searchable X509 certificates. But we need the support for that before we can properly implement our index. So those are coming. The authentication service we have now, we have tested OpenLDAP. We've got a small-scale operational authentication server. We've tested software called LIMS for the authentication server index. That's about to go operational. The tests have been, they've gone surprisingly well. Currently we have a plugin for Apache 1.3, and it's small-scale operational. When I'm saying small-scale, it's like a few hundred users. FADA is aiming at a couple of million users, a couple of 100,000 servers of the kind I show you, the nice green servers, and hopefully no more than 50 to 100 authentication servers. And we have a Java API that's underway, and both of those plugins are going operational during this month. That was the status. So how do we put data into the system? We take it, as I said, from the authoritative data systems. Students, that's okay, student registry. Payroll system for employees, that's okay. Others, people that should have access to parts of the university, either to the computer systems or to the buildings themselves, we take from various sources. This is a problem. What we've also done is we defined the ownership of the user administrative data. And this data is entered by and inserted into the system by administrative staff. As I said, normal user categories: employees, students, others, aliens, strangers. Either employees from outside your own university, for instance, a professor flying in from another university to give a lecture, or a student that's taking a few courses in your university. And that's actually going on in an amazingly big scale. There's somewhere around, the last number I've seen bandied around is 50,000 people are doing that. And the delegation of right is an administrative procedure, not something the IT department should do. This is the major point of the presentation. Tidy up your user administration and get the administrative staff to do the job they're supposed to do, even though it involves these new fashion computers that haven't been around for more than 20, 30 years, when they're still doing their work with pen and paper. Get them to use the computers. Then what we do with the data, we put them into the user management system. We import all the data. We do the integrity checking based on social security numbers. And we do have a license to use social security numbers at this backstage level. And then we export just a small view of the data onto the authentication server. And then, of course, you can also use this because you have all the information about the users. You can export this to Active Directory, to NIST, to the radio server, to whatever systems you need that also needs this integrated, federated user management system. And bots, in our context, is just the processing part. We've been very concerned about privacy. And this is not just because of the privacy legislation that's been passed in Europe. It's because we genuinely care about the users. And I know it's weird, but we do. And we have lots of people who do that. We use strong cryptography to protect the data transfer. And wherever possible, we use that for data storage as well. There are some systems where you have to choose between one or the other, like radios. You can either transport the passwords in clear text or you can store them in clear text, and that's whatever, pest or cholera, your choice. But the requirement is strong crypto wherever you store information about users. We also design the system so you never ask for more than you need. If all you need to know is that a person is affiliated with a university, you don't need to know which university, you don't need to know the person's ID, then that's all you're allowed to ask for. And this is implemented by a second layer of access control that runs between the servers and the authentication servers. And as I said, we have support for multiple identities per person. The data model we're running with right now is EduPerson. And we're using EduPerson 1.5 on the test server, 1 hour on the production server right now. By the end of the week, it should be 1.5 on both systems. The extra attributes we need is the NOR institution number, which is the official institution number that's registered in the official government databases. The NOR org unit number, because we need org unit numbers in order to assign rights. Birth date, that's mostly for convenience, because birth date is also part of the social security number. And that's the NOR SSN, which gives us the Norwegian formatted social security number for each user. And that's not accessible from the outside. So if you try to connect to our LLab server and get my social security number, you won't get it. If you want it, you can look it up in the architectural documents for FADA because I've used it as an example. But in principle, it's not available. And we have some supplementary local object classes that we've added that we found out we needed. We need some information about organization, organizational units, and some more information about persons. And when we export data from the user management system, the authentication server is accessed currently over LDAP from, as I showed you earlier, a network service backend. And even though the drawing was with the client-server model, in principle, there's nothing stopping it from being peer-to-peer and each individual host having a backend like that. We haven't tested it with typical peer-to-peer applications, though, because people have asked us to do the web server first. And the credential types we have right now, we're running with username and password. We will have support for certificates. We plan on buying the certificates or at least for the end users. We don't want to run our own certification authority. We're also using certificates between the servers, but that's a bit of a different story. We are working on role definitions, and there are some policy modules that are also currently on the way. The authentication index server, this is one of the things that makes this different from, for instance, the US work, is that they have something called a where are you from thingy that sits in the middle. And currently that's implemented as a list where you have to choose where you come from. In our case, you can be registered as a student in one university and as an employee at another university, and we will still find you somewhere in the system. And if the server has the right to get that information about you and it asks the authentication service, it will get redirected to both the instances. So we're using LDAP redirects from the authentication server, from the authentication index server to the authentication server. We're indexing the LDAP servers by extracting tagged index objects. And currently we're using a software called LIMS. And the status on that, as I said, testing it, about to go operational. Testing has gone well. We tested it with 500,000 users on one LDAP server. It takes a while to build the index, but apart from that, it seems to be working okay. We don't currently have any LDAP servers or authentication servers with that many users on it, but we know we have to scale big, so we just wanted to test big. And we know that it scales with many users, and it seems to scale with a small number that is 50, 100 LDAP servers without any problems. Further work we're planning on is authorization. For those of you who listened to Roland Hedberg last afternoon, well, it was getting kind of late. His work is the basis of some work we'll be doing together with him. Scaling issues we need to look into, and that has to do more with roles and role management and policy than with the actual things we've done so far. Because in a complex organization like a university, the role management is difficult, and you have all these weird relations. You can have a professor who's on holiday and then becomes a student, and he should have student rights on parts of the service and professor rights on parts of the service, because you don't really lose your professor rights ever if you ever became a professor. And then maybe he comes back and he's elected into the board of the university, and then, well, it's a mess, and we need to figure it out. So there are some rather tricky scaling issues on the policy and the delegation of rights that we are going to work on. We want support for client certificates and smart cards. We want, or we need, to build plugins for more network resources, not just web servers. And we want integration with parameter control, because what we've built for is really server control or a box somewhere. And we want to be able to use it also for parameter control so that all the authentication services integrate. Who does what? The user information providers are the universities. And what they do in this context is user administration. The FADA project does testing, piloting, and we will be producing a handbook. We do proof of concept software. We try to build on existing software as much as possible, but some of this just hasn't been built or isn't available as open source. And we are going for open source on most of these modules. We will also come up with a legal framework and make standard contracts that people can sign, because you don't get access to privacy information without having signed a contract. And we will be providing an operational authentication server index. The information and service providers, on the other hand, they can just replace the local user database that they use to authenticate currently with a plugin for the authentication service. And that's it. What complicates the matter is, of course, the fact that an information and service provider can also provide users or parts of the user you need, but this is really, it turned out to be much simpler than we thought when we started doing it. And what we've done is, as one of my former colleagues have taught me, all internet services need a root. They need somewhere to belong. In our case, the top level of our system is the authentication server index. They also need a data model. That's something we're working on. What we're using now is eduperson and something, some other LDAP schemas. There's a model for how we do unique identities. There's more work to be done on the data modules. And the transfer protocol, currently we're using LDAP. The reason we're using LDAP is that the real hard part in this is defining roles and groups and rights. And there are some schemas that exist. So we're using them, at least the prototype. LDAP gives us all these neat things like cross-platform implementations, server backends. And we know this system is a read many, write few system, which means it probably is a directory something, or maybe a database, who knows. It also gives us support for X509 certificates, something that we need in order to have qualified signatures, which we plan on piloting later this year. And indexing information from multiple LDAP servers is a piece of cake, because we've done that before in the Nordic Enhanced Education Directory Service. And if you want more information, that's the website. It's mostly Norwegian, but there's some English, and I keep putting up more English information. If there's something you wonder about, email me, email both, stand up. He's the one who's done most of the user management system stuff. So email him if you have tricky questions about what to do on your university.
Okay, thank you, Ingrid. Do we have any questions? Any questions? Okay. Oh, one at the back.
Well, you mentioned use of the two student databases. Is that content-wise or tool-wise? So,
Two different student registry systems. So two different software systems. Each university has one, in principle, database for the students. In practice, of course, they have more because they haven't consolidated the systems after being reorganized, some of them, quite recently. But in principle, there are only two software packages that do this student registry system in Norway. And one of them is located at the University of Oslo, so they seem to be able to talk very closely with us.
But apart from that, the software they use internal to the university might be quite diverse. So it's just a registration part.
This is one of the reasons why we've spent quite a lot of effort to clean up the interface between this management system and the student registry system. And the API should be built when this becomes available, August, hopefully, maybe before, so that you can plug it into your local system.
Okay, any more questions? Okay, thanks, Ingrid. Okay, our second speaker for today is Stanislaw Osinski from Poznan Supercomputing and Networking Center in Poland. Okay.
Not Stanislaw Osinski, Cezary Mazurek. Okay.
Right. Okay. I've said. Right, it's the wrong speaker. Excuse me. Right. Our speaker is Cezary Mazurek from Poznan, and his presentation is titled Digital Library Framework.
Okay. Thank you, Rina. Sorry for the problem, but there are 4 authors, and we didn't know who will come until the end of the time. I'm from Poznan Supercomputing and Networking Center. This center is responsible for operating supercomputing facilities provided to scientific users in Poznan, and also is responsible for operating of national network academic and research and academic network and metropolitan network in Poznan. Personally, I'm involved in network services around this architecture, around these facilities. So I'm a bit involved in providing services for grid access as well as for network services access. That's why digital library framework is presented also here on the TERNA conference. We see digital library as not only as an application for content access like books or publications. Yesterday we saw in one of presentations that digital library was considered as an application, but on the other side we see it also as a service for applications. So universal access to the content provided by digital library can be used also in other applications like distance education or portal access to computational resources or whatever. That's how we see it. So digital library framework we called the Libra. I will tell you what is it at first, and later I will go through some introductory topics, how we see electronic publication, what is our library organized, what versioning mechanisms are available, what are access management methods. I will present shortly the functionality on slides only, and I will present on one slide next deliverables we plan to have in the near future. So, System for Multimedia Content Management and Electronic Publishing. That's what our framework is. We are developing it internally in PSNC, and it is funded also by PSNC. The framework was created to facilitate some main operations during publication process, and it supports three basic roles in the publication process. This is reader, editor, and publisher. The system was deployed in PSNC in May this year for internal publication, for management of internal publications. So, digital library framework, the Libra, supports, as I said earlier, publication process, and it is used for setting up and access and maintaining of library content and digital documents, which can be of various types. It manipulates and it allows to manipulate the contents through GUI applications written in Java mostly, and it provides users with library content access tools for searching and browsing through web. There are examples which will come later also. So, to have digital library framework, we had to define what is electronic publication for us. Of course, this is a separated and well-organized unit of content. It can be scientific paper, report, book, and also, as we see it, website. So this is not only one single file, like PDF or MS Word, but this is also a set of files structured in the directories and like HTML pages, which is managed in the digital library framework system. This is not only the electronic publication is not only the electronic version of written paper. It's what I wanted to stress here. So the life cycle of electronic publication, as we see it, is that somebody will decide to create the publication, so she develops an electronic document. Then the document is uploaded to the library, and somebody enables access to this document for users through web or through palm tops or whatever. And then the author decides to modify this document, and then he wants or she wants to upload the modified files to the library, and then somebody enables this new version for library users. What the Libra is not doing, I don't know if it is visible, but it is not handling those two parts which are related to addition of documents. So this is not developing of electronic document, and this is not possible to modify electronic document. The rest of functions, it must be done by external editor like Word or HTML editors or whatever, and the rest of management functions are handled by the framework. The content in the digital library we designed makes at first the library easy to use for the readers. So we introduced the hierarchical library content, it's normal, and we entered metadata schemes to describe the publications. So the library content allows administrator of the library to manage the content and to manage the access rights to the content, to directories or to whole library. So from the root directory, there's possibility to have the folders, thematic folders, and then there's in folders there are publications. It's easy and it's clear. But the publication, it's a folder, in fact, and it can be have the other folders inside and files also. So it is composed of different objects, and those objects are separated and separately managed and separately viewable in the library. As far as metadata is concerned, there's a possibility of defining multiple user-defined attribute schemes for every entity in the library. So also for these objects like images, which are components of the publication. The values are stored in multiple languages. User can define the language. I mean the administrator. And we entered the predefined Dublin Core metadata scheme in the library. Okay, third issue in that topic is document versioning, which we implemented. It lets document to be developed freely, and there are two levels of versioning: the document level of versioning and object level of versioning. You know what is object and what is document according to the definition which I mentioned. So users can manage subsequent revisions of publications objects and of publications also through branching of versions of those publications and objects. So how it looks like when the author of the publication has this one file like this body HTML file with the version 1.1. He decides to publish it through the digital library system. He or publisher, because that's another rule possible to define. So there's edition 1 of the publication, which is composed only from one file. Then the author can modify the body HTML file, creating, for instance, next version, and then this he enters also another file to the system, to the library, like logo GIF file, which is taken together with version 1.5 to second edition. Both editions can be available in the library, or he can disable the older edition and replace it with a new edition. Then next steps are similar. Next versions of files and branches are appearing, and then the publisher decides which version are taken to third edition of the publication, and those operations can be repeated in the future. So there are two levels of data, of content in the Libra. There's publication level, which is visible for user according to rights which they have to that content. And there's object level, which is relating to components of those publications, which can be also accessed according to rights users have to those components. according, that's rights. So access management makes the library easy to manage. It's easy. And there are several levels of access management. The library administrator decides about the rights on the library level, so he can give the right to create a new publication or to create a new directory in the library. There's a directory level access management, document level access management. Those rights are assigned to 3 rows of users in the digital library systems. So there's an application called rights editor, which enables to alter this access rights to library objects. And for instance, for a publication, there are 3 rights. The view right permits to read all published editions, and the read permits to read all editions. Means that if there's an edition created and not decided to be available publicly for public access, there's another right to access it. And manage permits the manage publication, means create new versions, create new objects in this publication. For branch, there's 1 right only. It is edit right, which permits to update and put new files in the branch. So there are 3 rules in the digital library system, as I mentioned. There's a reader rule, which is a simple web-based viewing of selected publications for now, and searching and browsing library through web. What is more interesting for us, it's a second rule. It's a rule of editor, which can upload and retrieve publications or the components from the system. And for this rule, there's an advanced versioning support, which for management of revisions of publications objects of branching. Third role is the role of publisher, who manages library structure. So he decides what kind of files are assigned to which library catalogs or directories. And he decides about publishing and hiding publications, as well as manages access rights and library resources, like metadata schemes, for instance. So there's a startup screen. There's a Java application. Two applications are available: publication browser for editor and library manager for administrator. There's a login based on information from database. There's authorization in the future. We want to realize it based on LDAP schemes and LDAP attributes. But according application, which is used for rights management, we have to do this in the database for now. Okay, there's a publication browser. I don't know if I have some pointer. Okay, here, probably. Okay. So there's a publication browser. On the left side, we have the catalog of the library. We see the directories here like it is in the structure defined. And here, this is the publications. This is the first publication. It consists of main branch, 1 branch. And in that branch, we have the edition. The edition has 2 branches. And one of them, there are files which are defined for that edition. According attributes, we can define attributes value, and we can assign the value to each edition as well as to the objects or directories. When the editor decides to create a new publication, he has to show in the application where the main file of this publication is located in his local drive. For instance, for HTML files, there's usually index HTML file, which is shown as a main file of the publication, and then the system analyzes the content of the HTML files and get all the links, building the structure of the publication in the database. And then the consistency of the publication is concerned, means if any links appearing in the application which is not related to file on the local disk, there's an alert issued, or we can ignore this inconsistency alerts. And then the user upload the publication files to the server. Similar is with updating the publication, but user is allowed to choose files which are located on local disk, and he is allowed to update only several files based on a date of the file system. Recognize that this file is newer one, and shows which file were modified from the point of last update. According addition process, at first users have to download the publication to their local disk. So there's another wizard to choose the files we want to have downloaded, and then select files to be edited, and after it update the publication in the library. Okay, according next deliverables, we plan to extend the functionality about control mechanism for document review and acceptance, so a kind of workflow on the publication, workflow control of the publication. We want to enter the special browser for copy protection of the publication. There will be user notifying mechanism about changes in particular publication. Those functions are already in development stage. Content-based publication searching and full-text searching is considered also. Some management issues according interdisciplinary publications. That's the point of multiple assignment of one publication to different categories and different directories of library. Extended metadata model, also supporting open source databases. We now work on Oracle database, but that's a modular structure, so we can easy, and we want to extend the interface to another open source databases to let the system to be as open source available from our website. Publication editor based on well-defined structure for XML and style sheet editor. There are next points also which we want to provide with the systems, with the system. Okay, if there's a user guide for now, there's a user guide. We want to give also access to sources. I mean, to public it on our website. It will come in the future, near future, for somebody who wants to look in details in the functionality. There's a user guide in English which I can send based on email requests on that address here. Okay, thank you very much.
Okay, thank you, Cezary. Okay, do we have any questions?
Why did you not choose to develop in an applet application browser, but in a Java application?
Yeah, that's because of we wanted to have it independently of the web interface. We wanted to have the control who is using the application through the installation process on the disk, and just like issuing the program, the application. So that's, but it's possible. It's possible. We wanted to have it as external application, just for our purpose also. For instance, the browser will be extended. The browsing functions will be extended with applets because of deployment, which we are going to reach in the near time, and they want us to protect the copying possibilities of the content. So we have to put the browser in a form of applet with control of copy of publication content.
Thanks. Do we have any more questions? One over there.
Okay, thanks. Have you thought about handling variants next to versions? So for instance, if you have the same document or a document part in a different language, it still doesn't make it an old version, the other one. Or if you have a publication where you have a JPEG image and a GIF image of the same image, which can be considered variants instead of versions. Do you handle that?
You mean different types of files which can be considered as the same version, yeah? Or yeah, okay. It's not supported yet, but according metadata scheme, and this is like this problem with linking of files, because everything is object. The publication is an object, then the image is an object. That means that we assume that each object has only one parent. And for instance, we cannot assign the publication to 2 or 3 directories. This is a problem for us because librarians look for it, and publishers also. And that's why we don't assign objects like 2 publications, 1 publication to 2 directories. As far as images are concerned, this is also not possible. On the other side, what you're asking of is different versions of each object. Of each object, for instance, different language version. That's a problem because we analyze the links in file like HTML, and I'm afraid that's a larger problem because we have to ensure mechanism of automatic translation of links for different versions of image files if it is concerned. Any branch is possible. For instance, you can create a branch and you can create another edition for another file which is taken from the branch. That's the solution maybe.
Okay, thank you, Cezary.
Okay, thank you.
Okay. Right, our third presentation is from Antonio Costa from the University of Minho in Portugal. His presentation is titled A Framework for Multi-Class-Based Multicast Routing. Okay, Antonio, over to you.
Thank you. Good afternoon, ladies and gentlemen, here in this room and all who are seeing us through the internet, hopefully using some multicast technology. I'm going to present some work that is mostly being carried on by my colleague Maria João under the supervision of Professor Gruszczynski, which is titled A Framework for Multi-Class-Based Multicast Routing. I'll try to structure my presentation in these 4 major parts. First, an introduction, where I will present the current situation on multicast and quality of service, with a special emphasis on this architecture or class of service architecture. I'll try to show what the problem is and what are the solution requirements in this introduction. Then in the second part, I'll try to show you the framework that we're proposing. The framework has 2 major components, a multiclass protocol with a new technique for constructing the trees, and also a unicast class of service routing protocol. The 2 together provide a model for multi-class-based multicast routing with flexibility enough to allow for different membership KOS requirements. On the third part, I'll discuss the major advantages and expected improvements of the proposed model, and also its major known drawbacks and issues. I'll terminate with the current work and the future work that we have already planned. The goal of multicast routing is to build a tree or a set of trees connecting the multiple members of a group, and the packets are forwarded through the 3 branches from senders to receivers. There are a set of protocols that can build multicast trees. For instance, core-based trees, beam sparse mode, multicast OSPF, etc. Core-based trees build only one tree, bidirectional, centered on some core router. Packets are forwarded in both directions in its tree branch. Beam sparse mode uses 2 types of trees, one shared tree and one source-based tree. They are unidirectional trees, while multicast OSPF builds mostly source-based trees. In traditional best effort IP model, packets are forwarded if the nodes have resources, are discarded if there are no resources, or suffer from delays if the queues are, if you have big queues. All packets from all applications receive equal treatment, which is not perhaps a very good idea because some applications are mostly affected by bandwidth restrictions, others are affected mostly by packet losses, etc. In multicast applications, most of multicast applications are QoS sensitive by nature, so we need to integrate multicast and quality of service. With multicast, we have another problem because we have a lot of members joining, a lot of senders and a lot of receivers who specify quality of service requirements and when, since they are joining and leaving at any moment. So we'll try to propose a model flexible enough to answer these two questions. There are many proposals on quality of service routing, multicast routing. 3 of them are Cosmic, YAM, and QoS-aware multicast routing protocol. They all have a common strategy, which we can call path probing strategy. It's a 3-way uncheck method. New member sends a request towards the tree. Some in-tree node sends back a response message. The message collects information about path while traveling back to the new member. And the new member decides if that path satisfies his requirements or not. If so, he finishes the process by just sending a join, and the path is selected. YAM, for instance, has a one-to-many join mechanism. A new member sends the join request on a reverse path broadcasting way, which means that the request is forwarded on all interfaces except the incoming interface. Request packets have a time to live to limit the scope of the request. Perhaps one or many of those request packets reach in-tree nodes. The in-tree nodes answer back with a response message. The response message collects, again, path information while traveling back to the new member. And the new member selects back path and establishes it with a join request. So with this strategy, this 3-way uncheck method, the job of the multicast protocol is to find a tree branch that satisfies the new member requirements, but then perhaps we need some reservation protocol to keep the path quality over the time. So we need some protocol like RSVP, and this strategy of path probing is better suited for an integrated service approach. Integrated service, however, have scalability problems, and a new model is emerging, a new class of service model is emerging. This new model, there are no intentions to give per flow guarantees, only per class differentiation. We have only a few number of classes, and nodes inside a class of service domain give packets a treatment adequate to the class that they belong. Packets, when entered such a domain, are marked in ingress nodes in one of the classes available, and then inside the domain they receive the treatment coherently by all nodes according to the class of service they belong. So the problem is we need to adjust multicast protocols for this new class of service paradigm, because that strategies of path probing and resource reservation do not fit well in this new class of service model. We have some difficulties because since packets are marked when entering the domain, the job of marking is done by sources. So how can the receiver specify their needs, their requirements, the quality of service that they want? And how do sources know how to mark? Perhaps according to their own requirements. They start marking the packets according to their own requirements. There are also some challenges when putting multicast into the surf. Perhaps routing himself can help class differentiation. Usual differentiation is done using some inside node mechanisms, some queuing strategies. Each node treats each packet according to some in-node techniques. Perhaps we can help this differentiation using also routing mechanisms, finding different paths for different classes. It's a challenge that we also find in this problem. I'm moving now to the proposed framework. There is one key idea. Since we in class of service domains, we have only a few classes of service, perhaps the best thing to do is to build multiple trees, one per class of service. And since we want to have the flexibility to both senders and receivers specify the requirements, perhaps the two types of trees, perhaps we need two types of trees like in sparse mode, one shared tree and one or more source-based trees. With that, we may achieve flexibility. So the key idea is, why not to build multiple trees, one per class of service? Next question is, can we do that? How can we do that? Multicast trees are built normally using unicast routing information. New members explicitly join a group with a request message, and that request message travels using unicast routing information. So, normally each node has only one route per destination, the best route for each destination. So if we are using unicast routing information to build a tree, with that we can only build one tree. If we want to build multiple trees, we need to have alternative paths for each destination. So we need to have multiple routes for each destination. Perhaps one route or one path per class of service. So routing algorithms find shortest path according to some criteria, and that perhaps they can be modified coherently to find more than one route for each quality of service, each class of service inside the domain. So in order to build multiple trees, perhaps we need to have multiple unicast entries. So how this works, this framework? The first moment source and receiver join the group. When sources join, they initially mark the traffic according to their own requirements. So select one of the available class of service. They mark the packets in that class and they forward them to the rendezvous point of the shared tree. That's how sources join. Receivers, since they have no knowledge of the group when they are joining, they have no requirements yet. They don't know how many sources are sending traffic. So they must join all trees, all shared trees for all class of services available. After joining, they start receiving traffic. There is an initial period of membership where the receivers meet the sources and start to receive traffic in some class of service. And that's the moment where they have to decide to adjust or not to adjust the class of service of the traffic they are receiving. Now, according to their own requirements. So a receiver may decide, I'm receiving this traffic in this class. I don't want to receive in this class. I want to receive in another class. And in order to do that, we must now explicitly join the source in the desired class of service. Of course, it's up to the source to decide on whether or not to generate traffic in the new class of services that is being requested, because that might affect his service contracts. He's generating traffic in one class, in another class, that might affect his service contract. So this perhaps gives the flexibility for both source and receivers specifying their requirements inside the class of service domain. We think that this proposal is aligned with current IP multicast model because certain receivers can join and leave the group at any time. No previous group membership knowledge is assumed. And it also fits well in class of service environments because we don't break the simplicity principle that is inherent to the class of service model. We don't add not much complexity with the proposed framework. There is no path flooding, no reservation, nothing of that that could be too much, that could break the simplicity principle. However, we have a problem in tree construction because usually methods for constructing multicast trees are based on reverse path forward check. This reverse path forward check assumes that a link from one node to another is symmetrical. The route from one node to another is the same of the other node to the first one. But a class of service environment is by definition unidirectional. So perhaps we need to construct directed trees. Trees are constructed in the way that the traffic is forwarded from tree root node to the receivers or to the members, and not assuming this reverse path forward technique. There are many ways to do that. We are going to show one that is sparse in PIM sparse mode with an example. I will use this topology with 12 nodes, all belonging to a class of service domain with 4 receivers and 4 sources. For simplicity's reasons, only 2 classes of service, class I and class J. Of course, since we have 2 classes of service, we need 2 shared trees routed at the rendezvous point node, one with the dashed lines and another one with the full lines. We have sources that are marking traffic in one of the classes, class I, this one and this one. And we have other sources that are marking traffic in class J. And receivers joined both shared trees so they can receive packets from both classes. Of course, we have here two tree branches, but there is no packet duplication occurring here because we have only I packets from I sources and J packets from J sources traveling in this branch. So there is no packet replication on 3 branches for separated classes. Now I'll show you how a new member joins the group. The new member explicitly joins the group by sending a join message. The join message travels by best unicast path towards the rendezvous point. And while traveling from the new receiver to the rendezvous point, it does not insert any state information in nodes because the path in the reverse way might not be the same. So there is no need to install state information while the join request is forwarded towards the rendezvous point. After receiving the join request, rendezvous point answers with the join acknowledge message, one per class of service. So I have a join for class I and another join acknowledge for class J. And this join message do install route information at nodes. They create entries in the multicast routing table, establishing the branches. So they may follow different paths. So one is establishing 3 branches here, and the other one is establishing a 3 branches from here. And we have the new member completely joined the group, and he has 3 branches for the 2 trees for each class of service. After receiving some data, a new receiver sees that it's receiving packets from source S1 on class I, on class J, but he wants to move for class I, so he has to do that by explicitly joining this source, creating a source-based tree. This is done with the explicitly join request, which travels by the best unicast routing from the new receiver to source 1. This join request is marked on the desired class of service, and it's up to the source to decide whether or not to accept generating traffic marked in that new class. If so, the join request must be acknowledged with the join acknowledge message, which installs root entries at nodes. Here we must send a prune back to the rendezvous point in order to avoid that the traffic from the same source arrives at this node from two different interfaces. So you have to prune information from here. It's a strategy like the one used in PIM sparse mode protocol. So this ACK join packet will install a root entry at this node, and will create here a blocking entry to avoid packets from class I from source S1 to be forwarded from this link to this node again. At the end, the new receiver is now receiving data packets from source S1 marked in the desired class of service according to its own requirements. So, just to summarize, we have two major elements in this framework. This new multicast protocol that constructs directed trees from tree routes to the receivers. It uses two types of trees, shared trees and source-based trees, in order to give flexibility to the specific quality of service requirement specification. And it avoids initial negotiation or initial knowledge of group membership. Another piece that we need to do that is a unicast class of service routing. That means we have to have a unicast routing protocol that finds multiple paths for its destination inside the domain, and that creates one unicast routing entry per class of service if necessary. If we join these two pieces, the unicast class of service routing protocol and the multicast protocol that constructs directed trees, if you join these two pieces together, perhaps we can achieve what we have called the multi-class-based multicast routing. I'll now move to the implementation issues. We started by simulation. Our first step was to implement PIM sparse mode protocol, since we have inspired on it. The models already available in network simulator weren't close enough. They use a centralized implementation. The model that builds trees in the way PIM does is the ST model. Is centralized. It doesn't send control messages periodically, and you only have to use shared trees or source trees. There must be an explicit command to change from one tree to another tree. So our first implementation task was to implement PIM sparse mode again. And then we derived an implementation of the multicast protocol that we are proposing from that implementation with a new tree construction mechanism and the usage of the join acknowledge message that PIM sparse mode doesn't need. And we implemented also in the network simulator unicast class of service protocol based on link state. We modified the algorithm of the link state to find one route per class of service. Now the discussion. We believe that the proposed model gives flexibility enough for both source and receiver specify their requirements in terms of quality of service. It does not break the current IP multicast model because sources and receivers can join and leave at any moment without need to know what group members, who are group members. It is also, this multicast approach also fits well in class of service domain because there is no per flow or per cut computation, no floating strategies, only one tree per class of service, which we think is adequate to the class of service paradigm. And perhaps we can also have the routing protocols help in the differentiation, in the per class differentiation inside the domain. Of course, we have some drawbacks of this proposal. The first one is we increase the routing table size. Both unicast routing tables and multicast routing tables grow in a factor that is proportional to the number of classes inside the domain. But with a small number of classes, that is, we expect to have only a few number of classes. That growth is not, perhaps it is not such a big problem. And since we are building multiple trees, we are involving more nodes and more links in the packet distribution. Perhaps we can have some benefit with that also. That compensates the increase of the routing tables. Another problem is that with this strategy, the time latency, we have a greater time latency when new member joins the tree because the join request must travel from the new member towards the root of the tree and be acknowledged back. And that means we have a greater join time latency for new members. But that's the price we must pay to have directed trees constructed in the right direction. Directed trees are better in the presence of link asymmetries, and class of service domain is by definition unidirectional. Current work we have already implemented and tested the multicast protocol that I've been describing, but only in a standard diff-serve domain with no routing differentiation mechanisms yet. We have some results, and we believe that the protocol has the expected behavior and is feasible, but we need to have more competitive results. We have also completed the unicast implementation, but we have no results on this yet. The implementation is complete, but no results yet. And for future work, we intend to evaluate further the multicast routing proposal with several topologies and group compositions and compare the results with commonly used protocols, doing more exhaustive tests on that. Finish testing the unicast proposal, and then evaluate the two pieces together and perhaps conclude about whether or not what the advantages and disadvantages of having this, what we are called multi-class-based multicast routing. Thank you for your attention.
Okay, thank you, Antonio. Okay, do we have any questions for Antonio? No? Okay, well, thanks, Antonio. Okay, our final speaker for part one of this session is David Shotton from the University of Oxford in the UK. His presentation is on the development of the VIDOS system. If you just bear with us a few minutes, we're going to connect the laptop and get the presentation on its way. Sorry about this, we have a slight technical problem here.
Tell you that they apologize for the delay in my flight and the inconvenience to this session that might cause, particularly any last-minute panic to the chair. I'm not quite sure why the projector isn't showing my screen image, but hopefully this other one will. The reason that I'm not presenting through the main server is that, as you'll see as we go on, I have a lot of videos to show and a non-standard piece of software.
Tried the non-sync.
I'm sure that's invisible to everybody.
That's the problem. It's working anyway.
Okay, can everybody see that? Okay.
If people would like to move closer to the front, they're very welcome to do so.
Okay, just...
Oh, we're not quite there.
Oh, we're not? Okay. Okay, apologies again. If I'll just introduce our speaker again. It's David Shotton from the University of Oxford in the UK, and his presentation is to do with the development of the VIDOS system. David, over to you.
Thank you very much. Again, apologies for being here late, which was something I think I'm very fortunate to have got here at all after the original cancellation of my Aer Lingus flight. And apologies for these technical hitches. Thank you. What I want to talk about today is a system that we've developed for allowing you to customize videos over the web, to edit them spatially and temporally, to modify their encoding parameters. And this is part of what I perceive as a more general move towards network-centered services, where you get away from the situation where each individual has their own personal copy of a particular piece of software which needs updating on a regular basis, needs backing up individually and so on, and gives you a system where the most up-to-date version is on a server that you can access from wherever you are. It provides a simple and hopefully cost-effective way of doing work, and enhances the ability to collaborate between different groups because you're all using essentially the same system. But it does require a high bandwidth, particularly for videos. It permits the use of central databases for videos and video archives. Hopefully the high bandwidth permits real-time video viewing. And it allows you to move to a situation where you start to use personalized versions of media entities rather than standard versions that you buy off the shelf from the supplier. And I'm involved in two such network-centered computing initiatives at the moment. The first is the bioimage database that I will mention just in passing, and the second is VIDOS that I'm going to talk about now. I'll start by talking about the VIDOS prototype, then describe the developments we're engaged in at the moment, and give you a demonstration, and then conclude with some remarks about where we're going. So, the VIDOS prototype started out as a very simple Java application whereby a Java program ran on a server, sent an applet to a client, which allowed the client to specify parameters that would customize a video that could either be on the server or in some distant database. And 2 years ago, at the Terrena meeting in Lisbon, I presented this prototype. It enabled you to edit videos spatially and temporally over the web, to adapt their size or their format or their compression codec to meet the requirements of the end user. And this was in a time when, for example, it was rather difficult to incorporate any old video into a PowerPoint presentation. You had to have the right type. It was a way of repurposing a video to match the capabilities of one's PC. The video could be anywhere. It could even be on your own web server that you allowed to serve the videos to the VIDOS server itself. So it was a method of giving basic video editing tools to users over the web without the need to purchase video editing software. And if used to reduce the size of the videos, it enabled an increase in efficiency by speeding network transfers, avoiding bottlenecks, and reducing disk storage requirements at the far end. This was the opening slide of the session that Egon, who's sitting at the back, chaired 2 years ago when I presented this, and it was subsequently published in Computer Networks. So where are we today? Well, there were some limitations to the prototype. First of all, it was written by Thomas Boudier, my colleague at the time, who was not an experienced Java programmer, and there was some inherent lack of flexibility in the way that the software was put together. The format and codec choice were limited by those made available by the Silicon Graphics Digital Media Library that we were using for the conversions. This at a time when Silicon Graphics was moving out of presentation software, and they had largely abandoned supporting this digital media library. The user interfaces showed only the first and the last frame, and that made it rather difficult to undertake temporal editing on videos that had scene changes. We started developing this for scientific videos that did not have scene changes, but we realized that this was a limitation. And we weren't able at that time to splice together separate video clips to make a composite. So in our second phase, our objectives were to rewrite VIDOS completely in better structured modular Java, to provide more efficient and extendable software that we could adapt, as I'll show you at the end, for other purposes, and to overcome some of the limitations I've just mentioned. To expand the choice of codecs, to enhance the user interface, and to enable video splicing, and to mount a service available to the academic community. Well, if you go to www.vidos.ac.uk, you will find this is our home page now. Gives lots of information about where we're going, and it has a rather different back-end configuration than our initial prototype. It has a web server and then a mini farm, maybe one should call it a small holding at this stage, of slave processors that undertake the conversion tasks. The web server is used for user authentication, to serve the web pages and the Java applets to the clients and receive their parameters, and then to commission jobs for the slaves to undertake. It also looks after the video file store and eventually sends the customized videos back to the users. While the slave processes undertake the conversion tasks, and we have a system where, funding permitted, we can just add in more slaves and do things quicker. So the current architecture looks like this. It has similarities to the previous diagram. On the left are multiple VIDOS clients and multiple distant video databases as sources of videos. In the center, the VIDOS server with various Java threads running through it. Again, some local video store and a small database to look after user information and past histories and so on. And then over on the right, a variety of slave processors that can be used for the individual jobs. We've adopted for our prototype these wonderful old photographs by Edward Muybridge, taken to illustrate various aspects of animal motion in the later part of the 19th century. And here we see the Californian thoroughbred Annie galloping at full tilt. What he did is arrange 15 cameras to take 15 shots of this at different stages in one full stride, and we've just digitized these and made a little video that repeats that 6 times. So the original video that we're going to use as a test in this demonstration of what VIDOS can do is an a motion JPEG compressed video with a moderate quality setting, repeating this one stride 6 times to give a 90-frame video lasting 3 seconds at 30 frames a second. And the size of that is about 4 megabytes. What we're seeing here is a scaled-down preview of it, just for convenience. The user interface has 3 parts. The first allows you, and perhaps this might seem a cack-handed way of doing things, but it is in fact most convenient. It allows you, first of all, to select the output format that you want. You can select QuickTime or AVI or whatever, MPEG, the type of compression algorithm applied, if that's relevant, the frames per second frame rate, and the spatial quality low, medium, or high in the original implementation. And then you move on to the spatiotemporal editing interface that allows you to choose the start and end frame of the video clip that you want, the spatial area of the video frame that you want, to decide a zoom factor, and then move on to customize the video. So, for example, you can choose just the jockey and the head of the horse, and you can choose, as I've done here, to take just the first 45 frames out of this 90-frame video, and to de-zoom the video by a factor of 50%. You then go to the conversion interface and click the Start Conversion button, and parameters are sent to the server. You're told that they've been sent, and you get a progress report saying, in this case, it's 35% completed, and eventually that it's 100% completed, and you can then retrieve the video and download it to your local machine. So here is such a customized video, de-zoomed to 50%, just the first 45 frames, and so on. And what we've achieved in this is a file size of 91 kilobytes, a compression of the original of about 40 times. Now, this is the stage when, had I arrived earlier and we had time to assign me an IP number and I got the network hooked up and so on, which we can probably do in 10 minutes after this talk, but I haven't had a chance to do since walking in the door, we could go to Oxford and actually customize on the fly a video as a demonstration. That's what I'd hoped to do, but sadly we're not quite there yet. So I'll do what Delia Smith does and show you something I prepared earlier. So this is going to be the second, if I get it right, virtual digital dissection of a horse. So we just have to get the window so they all play at the same time and you can see them. But I think you get the idea. These are 4 different little videos that I've made using VIDOS, showing the head, the tail, and so on, all separately playing at the moment. And I'm going to now stop them playing because otherwise they will cause judder in my PowerPoint presentation. But you get the idea. Okay. So what benefits does that give us? It gives us the idea, the ability to, by reducing size, enhance download times, and reduce storage requirements, to enable free editing and customization, format conversion for people using the service, reducing their hardware and software costs, and enhancing, hopefully, their efficiency. For organizations that might have a central server of videos, this allows one to give distributed editing facilities, which might be useful to a university with regional campuses or a TV system with regional studios. And in particular, for educational use, it gives the ability to select the little bit from a source video that you want to show in your lecture or in your research presentation. It allows you to repurpose videos for different tasks, whether that's a live presentation or some computer-based training. It becomes particularly important and valuable if you can query it, if you can couple it, with a query by content system on the video database that you're going to search, so that you actually know and can find the type of video that you're wanting. And I'll come back to that point a little later. So we've got this system that works. We're seeking test users to really try and thrash our server and find out what the limitations of it are. We've been waiting quite a time to get to this stage, and we're glad that we're now here. So if people are interested, go to our website, log on using the registration form. They'll be sent a username and password, and we'll be able to try it. What do we want to do next? Well, as you noticed from the customization interface, we presented keyframes through the video that gave you glimpses of where you were, but not the ability to play the video on the client's screen. And the most important new development that we're working on now is that of a Java video player, which we call JVideo, that we can download to the client and allow them to play the video as a low-res streamed video to more accurately determine the spatial and temporal editing parameters that they want. And then we want to marry that to a system for interactive video analysis, which we called Ivana, to allow semantic content of the video. So I just want to briefly outline those things, and I will demonstrate that by a video showing cytotoxic T lymphocyte-mediated cell death, which is a particular biological topic that I study. And what we see here is a large triangular fibroblast in the center and a small cup-shaped cytotoxic T lymphocyte about to attack that cell, and then in time-lapse about 5 minutes later and 10 minutes later, you see the target cell starting to die horribly. And I will show you that. Just because it's fun to watch. So there's the poor dying cell going through its death throes. And what we can do with JVideo is to take the full timeline and restrict it to a particular section of the video, play that video. Here we see a number of clips from it. I'll show you it in reality in a moment. What I've got for that is another video. A rather Oxford video of a curious ceremony we indulge in each year called Encenia, when people dress up in funny clothes and parade around town and give thanks to their benefactors. So this is the full sort of promo video that I borrowed from the university. It was made 3 years ago, as you can see. Move that down a bit. It's obscuring the picture. So this is the Java video player. This is not playing in QuickTime or anything else. It's playing in some software that we've developed. And what we've got in here is the ability to select different spatial and temporal clips. So if we go here, why aren't you behaving? There we go. Let's say you just like processions and you didn't want to see the rest of it. What you could do is take out the 3 video clips that you see here and play them in succession, linked to one another, spliced together, omitting the other bits of the video. And we hope very soon to splice this functionality into the VIDOS system proper, so that you can specify clips using this video player and splice them together before you output. What all those other controls, which I don't really have time to go into, are for, is for semantic content analysis. So using these controls, we can specify an object in the video, Lord Jenkins or whoever it might be. We can define areas of interest, Lord Jenkins' head. We can get these to track with the object in the video. We can generate metadata describing these objects and events, the times and places of their occurrence and put these into a database which then is subsequently searchable. So that leads us to query by content. If we now combine JVideo and Ivana and also some other software I'm not going to talk about for automated analysis of simple videos like cells swimming, and a new query by content interface, we can create Vanquis, an integrated video analysis and query by content system, which will enable us to make queries such as, find me a video clip showing Lord Jenkins walking, find me the times of all target cell deaths that occur in the upper left-hand corner of the screen, or find me cytotoxic T lymphocytes that are serial killers and show me them in action. Where's VIDOS going now? Well, we've been very fortunate to get new funding as part of the Oxford eScience Centre for a project called VideoWorks for the Grid, which takes VIDOS as its core and adds other functionality around that. We have a number of eminent partners in this who are providing us with support of various kinds. And as I mentioned, central to this functionality will be VIDOS, and we'll use the same expandable Java structure that we've developed for VIDOS and the same server-slave protocol system to develop the VideoWorks system. We will marry that to Vanquis to allow interactive video content analysis, and we will store the metadata resulting from that in a video store database that's modeled on our other project, the bioimage database that I mentioned at the beginning. And then we will use some of the tools that our partners are providing for clever things like Flip Factory from Telestream for efficient transcoding, Video Logger from Virage for analysis of the structure rather than the semantic content of the video, and Video Charger for streaming the previews out to the clients. So VideoWorks looks rather similar to what you've seen already. There's a central server. Down at the bottom, there's a slave processor farm. Over to the right is another machine to do the Virage video logging. And to the left here, we have the multiple users and multiple video sources. And what we hope to do is VIDOS or VideoWorks enable a number of databases, the first of which will be bioimage. The second, hopefully, will be the British University's Film and Video Council Mass Media Online Archive, which has lots of footage for academic use. Users of these databases will then be able to link out to the VideoWorks service and either customize videos using VIDOS or analyze them using Vanquis and retrieve and store the metadata. So I just want to conclude by showing you the people involved in this. The rather doleful Frenchman on the right, on the left here is Thomas Boudier, who wrote the VIDOS prototype. Very nice man, returned to Paris for the love of his life rather than stay in Oxford, which was too hard for him. John Pybus is now the Java programmer who has completely rewritten VIDOS. Jamie Shotton, my son, is doing his finals in computer science in Cambridge at this very moment. He wrote the JVideo and Ivana software as his final year project this last term. And Danny Torbika is our VIDOS project development manager and Mac expert and webmaster. Last slide to conclude is to mention a new project called Songbird. What we're realizing is that ontologies are extremely important for all we're doing, particularly in databases. We need to be able to define the structure of the knowledge domain that we're working with, particularly for biological images and videos. And so we are seeking to launch a new collaborative project between various universities and research institutes called Songbird, Semantics and Ontology Generation for Biological Image Research Databases. And I mention that solely in case there are people out there among you who might be interested in a potential partnership. Thank you.
Okay, thank you, David. Okay. Do we have any questions for David?
There may be an opportunity later in the day, I don't know what the timetable is, to get the live demo working.
Yes.
I'll leave that to you.
Yep, okay. We'll announce for timing for the live demo if time is available. Okay. Oh, sorry, one question.
Hi. Well, actually, I had a lot of questions, but most of them were answered by your last few slides. One of the questions was about streaming, and you have the new VideoWorks project, and you will have the IBM Video Charger. So I guess you will do streaming with that. But do you support any kind of other streaming formats?
We haven't made final decisions yet. We haven't. We're due next week to receive from IBM all the software to match the new kit that arrived 2 weeks ago. We will then learn to use it and find its limitations, and we're thinking very much about QuickTime. But since IBM is one of our partners, we're going to give their product a fair shot.
Okay. Any other questions? Okay, in that case, I'd like to thank all our speakers for part 1 of this session. Just to remind everybody that part 2 of this session starts at 4 o'clock, so sorry we've overrun. Refreshments are being served, so thank you.